Okay, so this is 4.1. It's actually question number 7 from 4.1. So we're finishing. What is our plan today? Today we are to finish 4.1 and start 4.2. Uh-oh, okay. Well, at least we'll finish 4.1. Oh, 4.1's got 2 parts. I might not. All right, anyway, let's try. This is 4.1, part 1. There's a part 1 and a part 2. That's right. We better get moving. All right, so list each real zero. We did that. We did part A, like you guys were saying, right? We did part A last time, finding the zeros. Remember, you set each part that has x stuff equal to 0 separately. So if you set the x squared plus 16 equal to 0, there's actually no answers out of that part, right? Didn't we talk about that? Right? If you try to solve it, if you move this, you can just tell by looking at it, right? What could you ever put in there and then square it and then add 16 and have it be 0? When you square it, it's positive, huh? And then add 16 is not going to be 0. There's no way. You'd have to make this first part be negative somehow. Make it negative 16 to add 16, and that's not possible. It's not possible. If you don't notice that, that's okay. You should notice when you solve it. When you solve it, if you move the 16 over, it's negative, right? And then the next line, you put the root over both sides, and then you go, oh no, that's imaginary. Bless you. That's imaginary right there, because it's got a negative inside a root. Remember that? And so that's imaginary. So there's no zeros here. Nothing that can make that part 0. And then we go on to the other part. We say, okay, how about this piece? X minus 4 equals 0. You don't need the third power. I mean, the third, 0 to the third power, so it's going to be 0. Move the 4 over, that's clearly 4. So if x is 4, this piece will be 0. Which means the whole function will be 0 because they're times together, huh? If you make one part 0, they multiply together. Whole thing is 0. So yeah, x equals 4 is the only 0. What does that mean? That means graphically, only at 4 will the function go through 0. So it either goes like below and then goes above 0, or maybe it's above and then goes, whoops, missed it there, below, one or the other. But it only hits the x-axis at 4. The only place it's at a 0 height is at 4. That's the only 0. No other places. Okay, so now the others, that's where we were at last time. I don't know which of those yet. I will know in a minute. Part B, determine whether the graph crosses or touches the x-axis at each x-intercept point, this is the only x-intercept point, is at 4. So does it cross there or does it bounce? Did we talk about that at all?
No. Yeah.
Some say yes, some say no.
If it's even, it...
Yeah.
If it
all right.
bounces, and then if it's odd, it crosses.
Correct. Okay. Good. So we did talk about it a little bit. I know you were probably mainly thinking about the test material, though. So yeah. So let's talk about that. So add an x-intercept. Let me write that again. Add an x-intercept. Add an x-intercept. If it's got an even power, it bounces. If it's got an odd power, it passes through, or they say crosses, same thing. It passes through. Yeah, so that means at 4, now I don't mean the number 4, I mean the power. It's right there, there's the power. It's a third power, which is, of course, odd. So the power on that term, just the term from which we get the 4, the third power, so that's odd, so it passes through. So that means it's not going to bounce at 4, it's going to pass through. It's going to go like low to high or high to low. It's not going to go boing and bounce back up. Even powers make everything positive, don't they? So it'll bounce. That's why they bounce. Odd powers, positive, negative. So like x cubed, right? Positive, negative, passes through. All right, you know that. So, all right, so there's that. So at 4, it's going to pass through. C, determine the maximum number of turning points. I didn't give you that?
No.
Okay, let's talk about that. Max number of turning points. Turning point is where the graph is going up and then goes down, or going down and then goes up. Max number of turning points. It's how do you say it? It's the degree. It's the degree, but what's the degree? It's the, let's just say the degree. I'll define degree in a minute. It's the degree of f of x minus 1. So in other words, let's do this. Let's take that function and multiply it out and find the degree, and then it'll be easy. So the degree of this function is minus 8 x squared plus 16 x minus 4 cubed. Like that. Okay. So we have that right there. If I was to FOIL that all the way out, I don't want to, it'd be a big pain, and I don't need to. But I can get just the first term, just the front term there. How does that work? If I was to FOIL, yeah, can you see what it would be? If I was to FOIL boom and a boom, well, I would get minus 8x squared plus whatever, or minus whatever, who cares? I would get minus 8x squared. That'd be the most powerful part. And then if I was to FOIL out all these x minus 4, x minus 4, x minus 4, you know, third power, I would, the most powerful term I would get would be x cubed, right? X times x times x, and then other stuff. I'm just trying to find the most powerful term, the front term. If I was to FOIL this whole f of x thing out, I would get minus 8x squared from these first two, and I would get x cubed from this thing all FOILed out, would be the most powerful term. And then they would multiply each other, and the very front term would be minus 8x to the fifth, wouldn't it? Because powers add, right? Plus or minus smaller stuff that's less important. So you with me to there? So if you were to FOIL all that out, you know, this whole thing, just FOIL it, FOIL it, FOIL it, the front term, the most powerful term, would be minus 8x to the fifth. What does that mean? That means some important stuff. That means this negative means f goes down to the right. Negative is down. So when the front term is negative, that means eventually this function is going down as you go off forever to the right. It might be up and stuff in some other places, but eventually the down forces are going to win. As you go off to infinity to the right, it will go down, not up. Because that's the most powerful term. It's more powerful than this. So as you plug in really big x values, he's going to dominate. Like there might be a plus, even if there was 1,000, let me just make up a big number, x to the fourth, and then other stuff too. He's still going to win eventually, right? Because he's more powerful. You plug in 100 to the fifth compared to 100 to the fourth is 100 times bigger. Plug in 1,000. What if you go all the way to 1,000? 1,000 to the fifth is another 1,000. So it's going to be bigger. He's going to win. He's eventually going to win. The front term will eventually take over if you go far enough to the right. He will win. So whatever's on him is what we call the end behavior. I'm kind of doing part D and C at the same time. Is what we call the end behavior. In the end, it's going to go down because because the front term, the most powerful term, is negative. Negative 8x to the fifth. I don't even know what the other terms are, but I don't care. Don't need it. So determine the and now we could also do the max number of turning points. It's the degree, and the degree is the most powerful term's power. So 5 minus 1, 4 is the max turning points. That means at most, could be less, at most this graph will turn 4 times. So you know we already know it goes through 4, and now that it's negative, we know it goes down after that, don't we? But it turns at most 4 times. So it might be coming down like this and then go up. So there was a TP, a turning point. I don't know what it looks like, but it could, for example, have a turning point there, and then maybe it's got another TP here, a turning point. Then it comes down and it might have another. What do we say? 4? It might have a turning point here, a TP there, and then it might come up and have another TP there. And a turning point and go down, down, down. At most, it's got 4. It could have less, could have 3, 2, 1, or none. But it's got at most, couldn't have more than 4. 4 is the max turning points on that graph. And we know it does go down forever to the right, eventually. Only crosses the x-axis at 4. Never hits the x-axis any other place. We know that much we know quite a bit about that graph, just from this quick little analysis. So the max number of turning points is 4, and determine the end behavior. What they want you to write for part D, the end behavior is just the minus 8x to the fifth. They just want that front term on that. And we're done. Does that make sense on that? Questions I can answer on that? Is all well with that? All right, I'll keep moving. All right, so let's try that one. Let me write it up here for you. So x minus 5 to the third power and x plus 4 to the second. Like that. So try that. So first part A, list the zeros and their multiplicity. That means their power. So let's do that. So what are the zeros and what are their multiplicity? Which means just their power. How many multiplied, right? Power means how many multiplied, multiplicity. So what are the zeros of that function? What are the things x, which you could plug in for x, that would make the whole thing 0? What will make this one 0? Yeah, what could you put in there to make that one 0? 5. And what's the power on him? 3. His multiplicity is 3. In other words, there's 3x minus 5s, right? That's what we mean. Multiplied together. And what could you plug in for x here to make that part 0? -4, right? It's just going to be the opposite, isn't it, of whatever's next to x. And the multiplicity on that is 2. There's 2 of those. So, okay, that's part A. Part B, determine whether the graph crosses or touches. So let's go for each of those. So at 5, does it cross? So we want to draw a little graph. You don't have to do a graph, but so we know at 5 it does something, and we know it hits 0 at 5 and -4 and nowhere else, right? Just those two places. Those are the only x values that make that thing 0. So let's start with the 5. At the 5, does it pass through or does it bounce? Look at the power. It's odd multiplicity, so it passes through. Or they say cross. I'll just write what they say, cross. It crosses through. And at -4, the power is 2. It's even, so it bounces, or what do they say? Touches. It touches or bounces. I'll put a B for bounce. It's going to bounce there. It's going to pass through there. Good so far? On the graph? Stop me if you want to talk about it. Part C. Determine the max number of TP terms. Well, to do that, we need the end behavior. Really, they should put D before C. We need the end behavior. So let me let you do that. I think it's valuable. Give you a second. Can you find the end behavior on that thing? Notice if you were to FOIL that all out, what would be just the front term, the most powerful term?
1.
Yeah, if you FOILed this all out, you'd get 1x cubed, right? And you FOILed this all out, you'd get 1x squared, and times those together, 1x to the 5th. They want the power too. Not just the 1, but the 1, bless you, with 1x to the 5th. So there's the end behavior. It's positive, isn't it? Positive 1x to the 5th. Good so far? Everybody see that? So if you FOILed this all the way out, the very front term would be positive 1x to the 5th. Everybody see how I got that? Because this part would be 1x cubed times this part would be 1x squared. Multiply those together, 1x to the 5th. That's the most powerful term. The other stuff is smaller. So he will take over in the end. So that means in the end, off to the right, it's going up, up, and away, isn't it? I mean, it might do some turning stuff and whatever, but it's never coming down to cross the x-axis again, because these are the only two places it hits the x-axis, and it always will be going up eventually. I mean, it could, like I said, it could have some turning, but it's not going to go below the x-axis again. It's always going to be above, and eventually it will go up, 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 and away at some point, because it's a positive end behavior. That will dominate if you go far enough to the right. Plug a big enough x in, he wins over any other terms, right? He's the most powerful term. Okay, so we can kind of do the graph a little bit here. We can say, look, it passes through right here, right? Comes over here, and what's it going to do there? Bounce. So we know, now it could do a couple of little jagged turning things in between, but generally that's going to be the look of the graph, isn't it? I know quite a bit about this graph just from some of those basic observations. These techniques are pretty powerful about figuring out stuff about graphs. Good to there so far? So have we answered all the questions? Oh, what's the max number of turning points? Yeah, so what's the max turning points is what? 4, because it's the power, the main power minus 1. 4. So there's at most, there could be less, there's at most 4 turning points. Yeah?
Why is it minus 1 again? What is the 1% again?
There's not a minus 1. Where are you seeing minus 1?
Minus 1.
Oh, minus 1 there. Yeah, sorry. That's that's just the formula. I don't really have any. I mean, I can prove to you some truth about it if you want. That's just the you can see it's true if you look at a couple of simple functions like let me get rid of that. If you look at like x squared, right? X squared does this, as you know. Just think about what you already know. How many? There's only one turning point for him, huh? And his power is 2. See how it's one less? Now, careful though. That's max. What does x cubed do? How many turning points in x cubed? None. He doesn't turn at all. He starts low and climbs forever. He never goes from up to down. He has no turning points. Well, third power. So right. But so he has no turning points. So the maximum he could have is 2. Which means there are other x cubed functions, like maybe 2x cubed plus 7x squared minus 5x or whatever, that might have 2 turning points. But that's the most you're going to get out of an x cubed function, is 2 turning points. Some x cubed functions have no turning points. So it's the maximum number of turning points. Is that good? I think we answered everything there. Now we've got the end behavior. All right, I'll move ahead. I don't know. All right, so minus 3x squared, x squared minus 11. All right, find the zeros and the multiplicity of each. So go ahead and make a little chart like we did a minute ago. Find the zeros and the multiplicity of each one.
0.
So what x values can you plug in and make that thing 0?
0.
I mean, if you
Can't do the second half.
I know if you distribute the 0.
So what can I plug into this piece
0.
to make him 0? Yeah, just 0, huh? Is that okay? You can just plug in x equals 0. And what's his multiplicity? His power is 2. Good so far? Now what can I plug in there to make this piece 0?
Positive square root 11.
Or negative.
Oh, yeah, the root.
Plus or minus root 11.
I was like,
Right? Because root 11 squared, positive or negative,
yeah,
is plain 11 minus 11 is 0.
I just remember.
Now, I'm just doing it casually. I'll show you how to do it formally as well. So you'd have plus root 11 and minus root 11. They're both things that can plug in there. What's the multiplicity for both of them?
1.
It's actually 1. Let me help. Let me do it. I'm being a little casual. Let me be more formal. In other words, how you can see that is probably the best way is just to factor this thing. Because this is minus 3x squared, and this is x minus root 11, x plus root 11, isn't it? If you factor it down like that, you're comfortable with that kind of factoring? Remember, root 11 times root 11 is plain 11. Do you remember that from your algebra days? See, there's one algebra fact that, that I'm glad to help you with, that we need to remember to be comfortable. Root 11, remember, 2 of the same roots make a plain whatever. Remember that from algebra? Root 11 is plain 11. It's all kinds of, there's just millions. Really, this is what makes pre-calc hard, and calc especially. Just millions of algebra facts. I'm glad to help you with all those, but you can't just let them slide by and go, I don't know why they did that, but I'll just click the right answer and hope for the best. No, that means there's something you need to get straight. That's where I would write. I know you probably think I'm crazy, but I would have a piece of paper as I did my homework, because I didn't want to keep making Arby's roast beef sandwiches all my life. I would have a piece of paper, and when I saw something like that, and I was like, why? I would write question number on my paper. I'd write question number 9 on 4.1. Why is it root 11? How does that work? I'd see Mr. Pinnell in the halls, and I'd have my list, and I go, Mr. Pinnell, why did number do-da-da? And he'd show me, and then I go, oh, good, okay, and then next, then I'd understand, right? You can't let those slide. You got to be that serious about math and science. So yeah, so root 11, I'm glad to help you with all that stuff. It's plain 11, so that means that's the right factoring. Remember how to factor where you got a minus, right? You factor like that. So that means this is really, my point is that's first power and that's first power, huh? That's why they're both just multiplicity 1, like that. Is that good? That makes sense on that? So we have to factor that. Okay. Now you might think, well, Mr. Aaron, what about, I would say, well, why did you just make that XX also? Well, because they're exactly the same. they're not different. Whereas these guys are different. This is minus root 11, this is plus root 11, so we have them separate. They're different, aren't they? Whereas this is exactly the same, XX, so you just put a 2 power. If these were both plus root 11, they're not. But if they were both plus, I would not leave them separate. I would put a 2 power. Right? When they're identical, put them together, put a 2 power. But if they're different, then no. Separate them, keep them different.
So is that what?
Remember all that from algebra? Glad to help if you're rusty on that. So that's why they're both 1 multiplicity, and the 0, right? This right here, x is 0, is what makes it is a 2, because he's a 2 power. He's identical. Yeah.
So if the square was outside the parentheses instead of next to the x, it would have just been plain 11.
Totally. Well said. Yeah. Good. I didn't think to say that. That's excellent. Let me write that. Exactly. You're thinking totally right. Yeah. If the 2 was out there, yeah, then what could you plug in to make that 0? Just plain 11 now. And multiplicity would be 2, because there's a 2 power on that guy. You think, well, yeah, well, you can make 2 of those. Well, they're identical. We don't write 2 identical things, don't we? These are different, right? But, Camel. Yeah, exactly right. That would then be x is 11, multiplicity 2. Right, exactly. Everybody see that difference on that? Good, good. So all that, it really is, you know, people don't make, especially calculus, people don't make it through calculus because they don't know algebra well enough. I mean, not just my opinion. Ask any, it's just common, Google, you know, it's common knowledge among math teachers that that's the issue. So right now, if you really want to go the way of math science, you should think, I need to really know algebra. I mean, really. I mean, I know you passed algebra and everything, but you need to become a master of algebra. That's what calculus does. Is it says you're a master or you're not a master, right? That's why people fail calculus, because they don't, all these little rules they're not really crystal clear on. So get those straight. I'm glad to help. Tutoring, do your homework in the tutoring center. They'll be there to help too. All right. So do we answer everything then? So you can do the rest, right? This is bounce, so even power. This is what is it called? Cross. Yeah, cross. They call it cross. Cross, pass through, or whatever you want to call it, because it's odd power. And the rest. What's the end behavior? Let's do that. What's the end? If you FOILed this out, back to the original. You just go back to the original. If you FOILed that out, what would be the front term? Negative 3x to the 4th, huh? Yeah. So that's it's going to go down, isn't it? And max TP, max turning points, is 1 less than the highest power 3. Yeah. Good. All right. I'll move on if that's okay.